All right, so we want to find the equation of a tangent to the circle x squared plus y squared equals to 25. And this question is an interesting question because it actually helps us to understand a couple of things. Number one is that a circle is not a function. Okay, so this circle here doesn't pass the vertical line test, so that's not a function. And whenever we're dealing with such a thing, and the y is not written explicitly in terms of x. So here is the explicit equation. We usually, for almost functions, we have y equals to some form of expression in terms of x, and that's called explicit function. But in this case, when we have x and y mixed and we really can't, or it's hard to separate x and y and write the equation in terms of y, we call this an implicit equation. And there are x and y and mixed. Now, the other part of it is this: whenever we are dealing with a situation like this that is not a function, and we are asked to find the equation, we have to use implicit differentiation. Now, implicit differentiation is that you have to differentiate even the y in terms of x. So y will be the function of x. So it's actually related, and I'm going to show you how to do that. So here is the first thing we have to do. Basically, by the way, this is find the equation of the tangent line. We need to find the slope. So the first thing we have to do, we find the slope or the expression of the slope, and that means we need to find dy dx or y prime. Okay, that's what we need. Okay, so let's go through and then do the differentiation. So the first thing that we have to do, we have to differentiate both sides of this equation. So here it is. We're going to start with d dx. I'm going to use the Laplace notation of x squared plus d dx of y squared is equal to d dx of 25. Excellent. All right. Now, when we do this, then we'll notice that the derivative of the x squared is 2x plus. Now, here's the part that we need to be, the implicit differentiation comes to play. The derivative of y squared is 2y, but it's not, because the y is in terms of x. We are actually, is a function of x. The derivative of y squared is 2y, and then we have to add dy dx because we are saying that y is a function of x, even though it's not explicitly implied. So now, and then of course the derivative of a constant is 0. So now we have this equation in terms of dy dx, and we're going to solve for dy dx. Remember that dy dx was y prime, and that's what we want. So now we're going to go through and we're going to isolate dy dx. So we have 2y dy dx equals to negative 2x, and then dy dx equals to negative 2x over 2y, and therefore last piece, dy dx equals to negative x over y. This is the expression of the slope of the tangent line to that circle x squared plus y squared equals to 25. So now we are going to find the actual equation of the tangent line at 3, 4. I noticed that the original question didn't show that. So here it is. This is at 3 and 4, and that's the circle x squared plus y squared equal to 25. And we want to find the equation of tangent at that point. So here it is. Now all we have to do now, this is x, this is y. We're just going to go through. So this would be the equation of the tangent line. First we need to find the slope, and based on that, the slope will be negative 3 over 4. That's the slope. Okay, and then we're going to use the slope point form, and that would be y minus 4 equals to negative 3/4 x minus 3, and you can manipulate that and then make it nicer, and the equation will end up being all right. So this is the equation of the tangent line to that circle right here with the slope of negative 3/4, the final answer.